Okay, we're in section 12.4, and we're talking about inscribed angles today. So pause and warm it up.
Morning, Jenna.
Measure of angle BCA. Kara.
I said 63.5.
Good. And T is Sydney.
116.5.
And what is X, Michael?
6.
And Matthew, what is X in number 4?
12.
Good job. Okay, today's interesting. We're going to find the measures of inscribed angles. And we are going to use inscribed angles and their properties to solve problems. And you haven't done this before, but it's related to what we know about arcs and central angles. Okay, so it's like the next step. So we have an inscribed angle, intercepted arc, and subtend. And I'm going to skip over the string art. Okay, string art, could give us an application that you probably won't ever do. But let's just go here. So let's talk about what an inscribed angle is. Follow along, please, in your notes. An inscribed angle is an angle whose vertex, so an angle whose vertex is on a circle and whose sides contain chords of the circle. So if I was to draw that real quick, so here, if we have a circle, again, if we have an angle that is made up of chords, that means chords by definition have endpoints where? On the circle. So if we just choose some spot on the circle here, trying to show it here, and we just put a chord across here, and from that same spot have a chord there, we've now made an inscribed angle. So how is this different from a central angle?
It's on
It's on the outside.
Right, the vertex is on the circle like this, rather than like a vertex being at the center of the circle. Okay? So what do we know about a central angle? Like if I tell you this, what do we know about this central angle? If I tell you that, the central angle is 120 degrees, what else do you know? What do you know about the arc? I mean, the measure of the arc is the measure of the central angle that is formed by the endpoints of, this A and B form an arc which has the same number of degrees as the angle formed through ACB, right? So we're going to learn today that this angle ADB that's formed by chords like that has a really nice relationship to that central angle or the arc measure. Okay, there's a really neat little relationship there. So let's complete this. What should be here and what consists of endpoints? An intercepted arc consists of endpoints that lie on the sides of an inscribed angle. So that would be arc AB, right? And all the points of the circle between them. I'm going to erase the central angle just because we don't need it right now. We're just looking at the inscribed angle. So a chord or arc, we use this interesting word, subtends an angle if its endpoints lie on the sides of the angle. A chord or arc subtends an angle if its endpoints lie on the sides of the angle. Okay, so let's look at this with their little rule box. We have a relationship here of an inscribed angle called the inscribed angle theorem. So if we have an inscribed angle ABC, the measure of that angle is actually, do you see what it is? Half of what?
The intercepted arc.
And the intercepted arc is AC, so the measure of that arc would be AXC, right? AXC. So if I tell you AXC is 100, what is the measure of angle ABC? 50. It's half. And then the converse of that would be, what if I tell you that ABC is 25? Then what is the arc measure? 50. You're going to double it because ABC is half of the arc measure. So that's how we're going to use it today. Okay? And look at case 3. Notice that in case 1, a side of the angle intercepts the center point. In case 2, the center point is interior to the angle, the inscribed angle. And in case 3, the center point is exterior to the inscribed angle. But in all cases, it doesn't matter the case. the measure of the angle is half of the arc that that angle creates. It's intercepted arc. Okay? Notice that arc DF in this top example, we say arc. This is a really important word. I hope you're looking. And I see not everyone is. But this DF subtends DEF. So we're using that as a verb, right? DF, another way to say that would be what? Give me some other word for subtends. DF subtends angle DEF. Is the arc that's related to the inscribed angle? Any other word you could think? DF is created by a inscribed angle. So when you see this word subtends, you now are thinking it's an inscribed angle that has created it, right? And so that's different than a central angle. Subtends is related to just inscribed angles, okay? I think that's the toughest word of the day. The concepts themselves are not hard. So looking at the next slide, we have measure of PRU. You can see the arc measures given out here. That arc P to U is 118. So what will the measure, and don't say it out loud, jot it down, figure it out. What is the measure of PRU? I mean, your plan is the measure of PRU equals what? What did we just learn in the theorem? It equals 1/2, right? The measure of the arc. So when you substitute our known information of 118, what do you get? What do you get? Go ahead and say it. 59, right? That's not hard. Okay, now the next question is, look here. We have the inscribed angle is 27 degrees here. So now can you find the measure of arc SP? And Kaylin, tell us what you have?
54.
Good, so you are now doubling the degrees, the measure of the inscribed angle to find the arc angle. Good. Yes. This corollary says, this is not hard to imagine, if inscribed angles of a circle intercept the same arc or are subtended by the same chord, then their angles, of course, would be congruent. So that goes back to, I mean, look at this arc AB. Arc AB could be created by infinite, it's kind of hard to imagine, but infinite inscribed angles, right? So we have an inscribed angle ACB, we have ADB, and we have AEB, but by definition, all of them will be congruent, right? Because they all are subtended by this arc. So, kind of an interesting congruency relationship there. Okay. See if you can find the answer here. Come back and check. So, you're looking at this, somebody is suggesting 82 degrees because you're looking at this big thing here, but the problem is CFB is interesting. Is it on a central point?
I see.
Is it a central angle?
I don't see it.
No,
Yeah, but wait.
it's not inscribed.
It's not inscribed. Oh, actually, is this inscribed? CEB. CEB.
Yeah.
That's inscribed, and what measure is that?
It's
164.
No, it's half of 164,
Yeah.
right? Which, okay, so they are treating this angle as a central angle, so it's we could say that the chord that's formed, or I'm sorry, the inscribed angle that's formed by CEB is 82. Okay, so if we know that, how does that help us find the answer? They're saying that DFA is a combination of DCF, this angle, and CDF. Why is that? Exterior angles theorem. Oh, the exterior angles theorem. So we have DFA is the sum of its exterior angles. DCF and CDF.
I still don't.
Okay, so the question was, what is the measure of angle DFA? DFA is the sum of the exterior angles. So that's this theorem that an angle is the sum, an exterior angle is the sum of the remote, interior angles. And we said already that this is a linear pair, so DFA plus this missing angle
So you're saying,
forms 180, and these plus this missing angle equals 180. So anyway, we found that CDF is an inscribed angle, and it must measure 82, half of 164. And then measure of this DCF, our debate was, is this one 33-degree angle or is it two 33-degree angles? And it's one, and we said if there's going to be two, they would elevate one of these arcs a little bit so that you could see a separation. But now we simply add the two together, and we get the measure 115 degrees. And let's try finding the measure of ABD and arc, excuse me, BC. And come back and check when you have. Angle ABD is,
Is 43.
because it's an inscribed angle, right? So we can see that it's going to be half of the measure of the arc, which was 86. And then CAB,
60 degrees.
well, don't they give us that?
Yeah, I just gave us that.
So they must be looking for, they're looking for the arc BC though. So Kaylin, what can you say to that? They're looking out here for this arc.
It's 120.
So good. How did you find it?
60.
Doubled it. Doubled the inscribed angle to find the arc measure out here. Good. Okay, an inscribed angle subtends a semicircle if and only if the angle is a right angle. Isn't that interesting? So any right angle that you inscribe in a circle will give you the diameter or a semicircle. It's kind of a cool thing for the hypotenuse. So here we are with right triangles again. And that makes sense. We can put a right triangle in a circle. So if we have this, if we see that a chord is subtending, a circle, and we can see then that we know now that the triangle that's formed here is a right triangle, we now can fall back on all the things we know about right triangles. So can you find A in degrees?
10, 11, 12, 13, 14.
Okay, good. So we know that this must be the right angle, so 5A plus 20 equals 90. And so we just substitute and solve. And you're right. A equals 14. Very fun. Okay. So can you find the measure of angle LJM? Now, is that a right triangle, LJM? No. But what do you know about measure of LJM?
Half of LM.
That it's what?
It's the same.
It's the same. So
Same as 30.
Good, it's congruent to LKM. So we now can set the expressions equal. And Andrew, do you want to tell us what you get when you do that?
2 equals 7.
I'm sorry?
You get 3.5.
So you had 2b equals 7, and when you divide by 2, you do get 3.5. And but the question was, what is the measure of the angle? So let's make sure we answered that by substituting the b into either one. And the easier one is this one, right? Just substitute it and multiply by 3.
10
Okay.
10
Yes. Quadrilaterals, finally. Quadrilaterals, we know the sum of the interior angles of a quadrilateral is 360, because we can have two non-overlapping triangles in any quadrilateral. So even if it's not a perfect rhombus or a square, rectangle, or whatever, we know that those angles are going to have the sum of 180. And an inscribed quadrilateral
360.
has 360, and we know that the opposite angles are supplementary. Okay, so, and then think about it, if the opposite angles are supplementary, we have two 180 degrees, which is what we need to make our 360. Okay, so it's a neat relationship. So we can use that to find angle measures, and here we have expressions and so on. Can you find the value of B. How would you set that one up, Kara?
You would
Where would you start here?
3b plus 25 plus 6b plus 20 equals 180.
And equals 180. Okay, so she's saying that the measure of angle G and J are together, sum 180, so she's setting them equal. So go ahead and find B. And then when we find B, I guess we have answered this question. And then, oh, actually the initial question says find the angle measures. So we'll substitute that back in. So what do we have? How many B's do we have, Kara?
Wait, what?
How many B's do we have?
Wait, 9 b's.
9B and then 45. Okay, so when we subtract 45, we have 9B equals 135, right? And who has B? 15 when we divide, okay? And now we can, notice we don't even have an expression for age, which we don't need, do we? We just have to find K and subtract that from 180. So we now just simply substitute and pause, come back, tell me what you have for these angle measures. Ways to look at it, but here we have the measures of all four angles. Very good. And you may pause and come back and check. Good. Okay, good. So we got 25. We have A is 3.
Wait,
And
so
then
you'd say-
do try these,
Did you say
please.
3 times 14A minus?
Okay, so we are, with Kara's help, we saw that this 31 is pointing to, in the triangle KJN, J and K. That's what this is pointing to. So there's that angle. And then we have the other angle of triangle KJN. Because of this, it being an inscribed angle, we know it's 19, half of the 38. So when we add 31 plus 19, we have the sum 50. So the unknown angle must be 180 minus 50, which is what we have, 130 degrees here. Kind of tricky to see. This one is far easier, right? And do we have those values? Anybody? Angle A is? And angle B? Angle B, we say is with the 18.
It's 20. No, it's 20.
Angle B? You're going to substitute 18 here.
85.
It's got to be bigger than that. There you go. Angle C, again with your x of 4. Oh, so guess what the other angle is? 95. There you go. Have a good day.
Okay, we have to write that down.